In mathematics, the rule of combination of two elements of a non-empty set S may give rise to the third element which might belongs to set S. The rule of combination sometimes might also give rise to a member which doesn't belong to that given set. In this video tutorial, we are going to consider different rules of combinations. These rules of combination are usually called binary operations. So first and foremost, what exactly is binary operation? A binary operation is any rule of combination of two elements of a given non-empty set. It's usually denoted with a symbol asterisk, but there are some other symbols that are used to represent binary operation. We have the inverted triangle, which I usually used to call it that way. We have a positive sign within a little circle, a product within that little circle, a minus within the circle, in fact, a division. Sometimes the connectives in logic are even used, either the conjunction or the disjunction. Regardless, you really don't need to pay attention on what symbol is used to represent the binary equation, but to pay attention to how the symbol is used to define the operation. So it is important to understand how questions involving binary operation usually used to look like, or how it does used to come. Well, it will be in such a way that you'll be given a particular operation, which will be defined under a given non-empty set, and you'll be required to combine two elements of that set so as to form the third element, which might belong to that set or might not be a member of the set. And that's just how it works. So what are we seeing in Excel? Let's consider some examples so you can actually see the visual illustration. So let's begin with the first one. Example 1. A binary operation asterisk is defined on the set of real numbers R such that if x, y is an element of a real number, then x asterisk y is equal to x plus y all divided by 2. So as you can see, the operation is asterisk and it is defined on the set of a real number. Now, if x, y, that is the two value, if they are from real numbers, then the operation will combine those two numbers to form the third number by just adding the two numbers and divide this by 2. So you will now be required to find some values. Okay, so let's begin with the first one. What will be 3 asterisk 2? Well, you just need to see that as if you are seeing x asterisk y. Okay, the order matters actually. Since x asterisk y is x plus y divided by 2, definitely 3 asterisk 2 becomes 3 plus 2 all divided by 2, which is indeed equals to 5 by 2. And that is the solution to the first part. Now on to part B, which is the second one. What will be negative 5 asterisk 4? Well, this is my x value and this is my y value. So all I need is to plug in these values in this equation. So then I have negative 5 plus 4 all divided by 2, which becomes negative 1 over 2. And for the third part, we have 1 over 2 asterisk 1 over 2. Well, in this case, my x value and my y value turns out to be the same. Well, I will still need to plug it into the equation so as to get the third element. So that will be half plus half all divided by 2. Half plus half is 1, then definitely results in 1 over 2. Now on to the last one. 7 asterisk 3. And that will be indeed equals to 7 plus 3 all divided by 2, which is indeed equals to 10 over 2. We can simplify this forward to have 5, because 2 in 10 is indeed equals to 5. And that is how to deal with problems involving binary operation. To ease your understanding in this topic, let's consider more examples. Example 2. A binary operation inverted triangle is defined on the set S, which is equals to 0, 1, 2, all the way to 5. So we are given how that operation connects two elements of set S. So it's connected in such a way that you will add the two elements and subtract the product of the element from the results. That's quite interesting. So we have to try and evaluate some two numbers being combined with that operation. So what will be 2 inverted 5? Okay, just like before, you see your x value as the first number and your y value as the second number. It depends on how they relate to those variables. So that's what we tell what will be what will be. Okay, perfect. So therefore, the third element by combining 2 and 5 will be 2 plus 5 minus the product 2 times 5. And this will eventually result in 7, as the product of 2 and 5 is 7, and minus 2 times 5 is 10, and will result in negative 3. And that is our result to that. Now on to the part 2, which is 0 inverted 4. 0 inverted 4, this is our x and this is our y. Becomes, so just plug this right into this expression. We have 0 plus 4 minus 0 times 4. Okay, let me put that within the parentheses. So that will result in 4 minus 0 times 4 is 0, and we will end up with 4. Now, onto the third one, 3 inverted 1. This is our x, this is our y. Then we have 3 plus 1 minus 3 times 1. And if we add this up, we have 4. The minus 3 times 1 is 3. So we have 3. And subtracting that, we left over with 1. And lastly, we have 4 inverted 5. And therefore, that becomes 4 plus 5 minus 4 times 5. 4 plus 5 is 9. And we have 9 minus 4 times 5 is 20. We have 20. So 9 minus 20 results in negative 11. And these are the final solution to these problems. As you can see, you can clearly say that the operation inverted triangle doesn't in all cases gives rise to element that is a member of set S, even though it combines two elements that are from set S. So that's how rules of combination works. I hope you find this helpful, and I believe by now you should be able to handle problems involving binary operation. So here is your exercise. Feel free to share your solution with me in the comment section below. Also, if you have any question, just let me know in the comment section below, or you have any comments about this topic. Thanks for watching once again. See you in the next video. Bye for now.